Okay, for this problem we're finding the inverse transform of this function capital F of S. And again, what I want to do is I want to write our F of S here as e to the minus 2s and then g of s, where g of s is this negative 2s minus 10 over s squared plus 8s plus 17. Okay. Now one thing I might note here is that I can't factor this denominator, right? This is, how can I tell that if I have a quadratic? My b squared minus 4ac tells me that, in fact. My 8 squared minus 4 times 1 times 17, I get 64 minus, what is this going to be, 68. I'm going to get negative 4 is less than 0. So if I used my quadratic formula on the denominator, I would get complex roots. So I know I can't factor that. Instead, what I want to do is complete the square. So I have a s squared plus 8s. I take half of the 8 and square it. So I want to have a plus 16 here. So I'm going to write my g of s here is negative 2s minus 10 over, so s squared plus 8s plus 16 minus 16 plus 17, right? I'm just adding 0 in my denominator here. So this is going to be negative 2s minus 10 over an s plus 4 squared plus 1. Right? Negative 16 and 17 make 1. The first three terms here, these make a perfect square. By design, that's how I chose the 16. You know, if you multiply this denominator out, you'll get what we started with, right? Now, unfortunately, I don't have anything like this in my table. For my table, I have a s minus a over s minus a squared plus b squared, and have a b over s minus a squared plus b squared. So what am I going to do here? Well, if I've done this once, I've done this a million times. I'm going to replace my my s there by s plus 4 minus 4. So my g of s, I'm going to write it as negative 2 s plus 4 minus 10 over this s plus 4 squared plus 1. So I have negative 2 s plus 4 plus 8 minus 10 over, now here I have what, I still have my s plus 4 squared plus 1. So write this as negative 2. Then I have a s plus 4 over s plus 4 squared plus 1 for this first part. Then I have plus negative 2 times 1 over s plus 4 squared plus 1 here, right? Okay, well, these are in my table. I can have my first one, so this, my inverse transform here, my little g of t is going to be negative 2, and from this I'm going to have a e to the minus 4t cosine of t from my table, right? The 4 here gave me a negative 4. The 1 here was b, gave me cosine for this expression. And I have a minus 2. And then this one gives me e to the minus 4t sine of t, right? So I'm almost there. I know my Laplace transform, well, inverse transform of f of s here is going to be u of t minus 2 times g of t minus 2. Okay? So finally, I put everything in there and I get my final answer here, u t minus 2. Then here I have a negative 2 e to the minus 4 t minus 2 cosine of t minus 2. They have minus 2 e to the minus 4 t minus 2. And then I have a sine of t minus 2 there. Okay, so fit all on the one page. Because I had to put my t minus 2 into my function here to get what my inverse transform was here. And, it's kind of a long problem, but it does work out.